I am Venugapal, Assistant Professor, Department of Computer Science, UG, K.S.Rangasamy Arts and Science College, Tiruchengode. So, today's section we can see the tree basis. Before that, we are going the introduction about the data structure. So, what is data structure? You know that a data structure is nothing but it is organize the data in a computer memory. In that computer memory means you have two different types in the data structure. You know that already you have to discuss it in that previous session. So there are two different types in the data structure. One is the primitive data structure and another one is the non-primitive data structure. In that primitive data structure, that means C language. In that primitive data types, that is C language means what are the primitive data types in that C means so integer, float, character, tuple and pointer. And non-primitive data types means that means again it will classify into two types. One is linear, another one is non-linear type. In that linear, we can see the what is meant by linear and non-linear means. So before that, what is linear means it's nothing but linear means it's a sequential of arranging the data in a memory. That means we already have to see that in that array and linked list and stack and queues. These are the linear data types in the data structure in that. In non-linear means tree and graph. So in array we can know that it's a collection of memory, that means stored in a sequential memory, that means one after another, that is called as a linear memory. So linked list and stack and queues. So in this section we discussed with a tree. So this is the basic introduction about the data structure. So now we go for the what is tree and why we go for the tree and what are the application in the tree and what are the tree terminology we can discuss in this session. So tree. So tree already said now, that means a tree is a non-linear data structure which organizes the data in a hierarchical structure that consists of node and is connected of edges. So you have to see in that figure here this is the one of the tree structure. So A, B, C, D. So like that. So here the tree with 11 nodes and 10 edges. In any tree with n nodes will be maximum of n minus 1 edges. So in a tree, every individual element is called a node. We can see in that detail. Why we go for the tree? Because already we have a lot of types in the data structure now. Why we go for the tree? So why we go for the tree? So a tree is a nonlinear data structure, already said that store the data elements in the sequential form. That means in operation in a linear data structure, the time complexity increase with the increased data. So that means you have to see the figure. So in a computer memory, we can store the data like 10, 20, 30, 40, 50, 60, 70. So we can take the data for that 70 means we go for the 10, 20 like that. In sequential manner, it will be very difficult. That means time complexity. So in this case, we go for the tree data structure. In this way, we have to go further. So what is tree data structure? So in this figure, we have to look like that. So in the previous slide, we have to linear data structure now. So it's the tree structure. So in this way, I have to search for 70 means it will be randomly I have to search. So likewise, we go for the tree data structure. So tree data structure is a non-linear, allows easier and quicker access to in the data element. So quicker access in a data element. So now we go for the what are the terminology used in the tree. There are a lot of terminology used in the tree. So namely root. So first node, that means is called as a root node. So I have seen that figure. So already I have to previous diagram. First node. So here A is a root node. Every node must have root node. There must be only one root node in a tree. So root node does not have any parent. So like that I have to see in the diagram. So here A is a root node. So in any tree, the first node is a root node. So A is a root node. Edge. What is edge? So edge, it's nothing but the connecting link between any two nodes. So connecting link between any two nodes. So here the A and B. So these two nodes, there is a link, that is a edge. So in a tree, there is n number of nodes. There will be a maximum n minus 1 number of edges. So you have to see the diagram. So parent in data structure, the procedure of any node is called parent. You have to say like that. That means the parent node can also defined as the node which has child or children. So I have to see in the diagram. So here A is a parent means the B and C as a children of A node. So here the B is a root node, that means parent node means that D and F, E is a child node. Child. So what is child? So the node which has link with the parent is called child. So I have to see that the diagram. Here the A is already known that the parent node. So the A parent of means B and C are children of A, and G and H children of C, and K is a child of G. So this is the child of the root. All the node except the root node of called child. Next one, siblings. So siblings, that means the nodes with the same precedings. So same precedings is called as siblings. So in a tree there is a B and C and same level, that means any tree the node which has same parent is called siblings. So here the B and C are siblings, and D, E, F and G, H, these are siblings. The children of the parent is called siblings. Leaf. So leaf, what is the leaf? The node which does not have child is called leaf. So the node does not have a child is called leaf. So in this figure, so which is the leaf node means you have to set like the I or J or K. These are the leaf node. So because any tree the node does not have children is called leaf. Internal nodes. So internal nodes, its internal nodes at least only one child. So nodes other than leaf, node other than leaves called internal node. So in this diagram, which is the internal node, that means so D, E, F, so everything, that means the apart from that I, J, K, so is not a non-leaf node. So other than nodes are a internal node. Degree. So degree of the tree terminology. What is degree of the tree terminology? It's nothing but it's a data structure. The total number of children of a node is called degree of the node. So here the see in the diagram. In this 3 level, that means 3 degree. So total of any tree, the degree of the total number of children it has 3. So here A is a 3 and B is a 1, 2. That means 2, and here I is a 0 level. So this is the degree of the level. And next one, level. So in tree data structure, what is level? The root node is said, the root node is said to be level 0. So here the children of the root node are at level 1, and the children of the node which are level 1 will be level 2 and so on like that. So here you have to see in the diagram. Here A is a root node. That means already said no, root node is the level 0. And next stage the B and C, the level 1, and next stage level 2. So like that we go for the level. What is height? So total number of leaf node in a particular longest path is called height of the data structure. So in this diagram, so 3 levels. So already the degree of 3 means you have to height of same like that degree of 3. So in any tree the height node, so total number of edges from leaf to the longest path is called height. So any tree of the height of the trees is called a root node. Path. What is path? So path, it's not total number of edges from root node to particular node is called path. So here the path, A is the path like that. So B and C and D. So any tree, the depth of the node, that is nothing but the total number of edges from root to the node. That means the depth of the tree is total number of edges from root to leaf. So is called depth. The path, the sequence of node and edges from one node to another node is called path between the 2 nodes. So here any tree, the path is a sequence of node. So like that. So here A and B and C, this is the path of the here. So here the path is a sequence of node, edges between the nodes is called path. Subtree. So what is subtree? So subtree, it's nothing but every child from subtree on its parent node is called subtree. So these are the basics about the tree terminology. Basis, we go for the what are the types in the tree, that is the binary tree and binary search tree. So in all the data structure, we the common operation like that searching and sorting and insertion, deletion, updation. These are the operations performed in all the types in the data structure we can use. In that binary search tree, we go for that in detailed manner of what is the tree, how used in the data structure. We will see in the next class in the tree section. Thank you.